This video is sponsored by PCBWay. With all the record attempts happening at Scuba and the 2026 F1 season just around the corner, it's the perfect time to build an over-the-top Aero package for the sim-controlled RC car. Before we start, I'm not an aerodynamicist, but I do get yelled at by a few for 2 hours every day. So let's see if I've learned anything over the past 8 months, or if I've just Dunning-Krugered myself into a project. Again. To test this, I'm going to need a way to visualize the flow. I looked at wind shear and A2, but they're way out of the bits budget. So I built my own wind tunnel out of foam board, straws, and duct tape. The key was getting the airflow straight enough so that the smoke behaves somewhat predictably. Ideally, you want low turbulence flow, laminar if you can get it, smooth layers, minimal mixing, but the Reynolds number in here is definitely high enough that turbulence is always trying to happen. So I used baffles, screens, and 1,000 straws to knock the turbulence down. Taking advantage of Danny B's principle, I used the pressure drop in the tunnel to effectively pull the fog through my injectors without adding extra turbulence. Finally, after a month of Sundays, I ended up with 4 relatively clean streak lines across the test section. Each one is basically a tracer line. If it bends or breaks up, something disturbed the flow. Is it perfect? Absolutely not. We could go into blockage ratios, boundary layers, and velocity profiles until the cows come home. But more on cows later. To set a baseline, I tested the car in regular trim. No rocket mounts or chunky relays, but still everything I need to drive the car with the motion rig. As you would expect, it's a disaster. It's essentially a stairway of 3D bluff bodies, so let's break them down one step at a time. Our first bit of vorticity and flow separation happens on the bumper and shock tower. Some of the flow spills over the tower and some squeezes through it. Either way, it's a messy start. Next up, the camera. I think the footage tells most of the story here, but I'll try to unpack it. The flow hits the shock tower and separates off the top edge because it can't follow the sharp corner. Once it separates, you get a fast stream sliding past a slower recirculating region. That creates a shear layer. Shear layers are generally unstable, so they roll up into vortices. And what's sitting right in the middle of that mess? The camera. So it sits in slow, separated air that makes the shear layer roll up into bigger, stronger vortices. Last step, the antennas and wake. Over the video transmitter, the flow is surprisingly organized, which makes me think most of the spilling and outwash from the camera is likely happening horizontally. Remember, this is happening in 3 dimensions, but the lasers are only showing us 2. So the antenna itself is where it gets tripped into roll-up, a bluff obstruction and relatively clean flow. To me, it looks like textbook turbulent vortex shedding, but what do I know? Maybe some nerd in the comments can help me out. Moving down a bit, we see the same kind of shear layer we saw before, only bigger. Like way bigger. Fast flowing up top, slower circulating air below, and that velocity difference forms an unstable shear layer that rolls and churns into this huge, chaotic wake behind the car. So what can I do about an RC car that's less aerodynamic than a cow? Design and print a body, of course. This was my first attempt at making something using forms over a 3D scan. I'm pretty happy with the shape, but my printing, prepping, and painting could use some work. It kind of looks like Leroy the Savage and a McMurtry Spearling had a baby. There's something else that it looks like too, but I can't quite put my finger on it. With the body on, the difference is huge. The flow stays attached way longer, the boundary layer thickens downstream, and we've got a reduced wake. I tested a couple different sections to see if I got lucky on the center line, but the flow was fairly predictable across the board. I purposely vented the wheels too, because race car. So I tried to design the body to swoop back and wash the wake out. Whether or not it worked is TBD, but it looks cool, so I'm happy. Speaking of wakes, check out how small it is now. Keeping the air attached really helped. Don't mind the vorticity on the left, the floor and walls of the tunnel are pretty dirty for a couple of reasons I brought up earlier. A slippery car is cool, but big wings that move are cooler. So I designed an active Aero system for the front splitter and rear wing. This will let me change the angle of attack of the airfoils depending on how I want to drive. Low AOA for minimum drag, a bit more for some extra downforce, and maximum angle to act as an air brake. I'll integrate the servo control into the RP2040 system later, so I can have DRS and Aero adjustments on the fly from inside the rig. I started printing some components, then the Ender 3 decided it was on vacation. That's why I reached out to this video's sponsor, PCBWay. Coming from an R&D and manufacturing background, I get to play with a lot of cool toys at work. But at my home shop, I'm pretty limited by the tools I have. So rather than fix a 3D printer for the 4th time, rebuild a laser cutter, or sacrifice space for a CNC, I sent my designs to PCBWay. Full disclosure, I've used PCBWay for over 3 years now, and when I started making videos, they were at the top of my yes please list of sponsors. Aside from the obvious PCB manufacturing, they also offer assembly services. 3 and 5 axis CNC milling plus turning, sheet processing, including cutting and bending, and a whole gamut of 3D printing materials and techniques. The parts I got today are made out of SLS nylon, laser cut acrylic, and routed carbon fiber. So they should hold up well despite my driving skills. The craziest thing I've found about PCBWay is that it doesn't just pick 2 from the good, fast, cheap triangle, it hits all 3. I upload a design, get an instant quote, order it, and sometimes within a week, a box shows up to my door. So if you want to get to work on a project but don't want to get bogged down by buying, making, or fixing the tools you need to do it, head over to PCBWay.com and let their team of experts help you skip the headaches. After the parts showed up, I started putting the assemblies together. Beginning with the rear, I mounted the main element to the swan necks, then attached the beam wings and swan necks to the shock tower. This doubles as a rigid mounting spot and an ideal location for any downforce to be transmitted through. Next up, the servo mount. I'm still tweaking the locations and angles for this one, but it'll work for now. Finally, the end plates. I had one made out of white nylon and the other made out of acrylic, so we can see what's happening with the flow at various angles of attack. I'll replace these with carbon fiber ones later. Let's throw this bad boy in the wind tunnel to see if it's doing what I think it should. Right away, you can see at low AOA, the flow stays mostly attached, with only a small, tidy wake. Later, I'll program a button on the steering wheel to enable this low drag DRS position. As I crank the angle of attack, we start seeing separation and a dominant vortex structure form behind it. At this point, it's less efficient wing and more spoiler or air brake. We're building high pressure on the windward face and a low pressure separated wake behind it. That creates a strong adverse pressure gradient. The flow has to slow down and turn aggressively, so the boundary layer detaches, forming a separation bubble. The shear layer around that bubble is unstable and it rolls up into vortices, just like what we saw with the shock tower, except this time, it's deliberate. I'll program the controller to command high AOA whenever I jam on the brakes in the sim. Kind of like this. Watch how the wake changes as I go from DRS to air brake. It explodes. A more turbulent wake means more drag. More drag means more stopping power. Now for the front splitter and active elements. Some of you are probably well aware that a well-designed Aero package functions as a system. What happens upstream influences what happens downstream. Well, this probably isn't a well-designed package, but the more I iterate, the better it'll get. Hopefully. As I said earlier, I'm a big Time Attack fan, and nothing says Time Attack like a huge front splitter with diffusers and big fat dive planes. So I modeled some using the scan data. The active elements are bolted to the end plates of the splitter. They were designed for FDM in mind, but since I switched to SLS, I could have made my life easier and made it all one piece. Who knew my printer would have gave up the ghost, though? The dive plane is actuated with a small linear servo and returns with the help of a small spring. A linkage would have been better, but I didn't have any rigid wire that would fit the servo horn. With the servo and airfoil on, I mounted the acrylic end plate so we can see what's going on when I change the angle of attack. This one's a little trickier to test because it's inside the naturally dirty flow that's close to the edge and bottom of the tunnel, but I'll try to make sense of what we're seeing. If you squint, like really squint, you can see the same kind of effect that we saw with the rear wing. There's a small bubble that forms behind the wing at the lowest AOA, and it increases in size as the angle of attack increases. It's definitely not an ideal setup because the low pressure side, or the bottom of the wing in this case, generally does most of the work. Instead of a nice smooth bottom for the air to attach to, it runs into a ridiculous servo mount. So, did we successfully influence airflow over and around the car? Yes. Did we add a pile of downforce to rip around scuba in under 50 seconds? No. Slapping random wings on things won't make us fast, but iterating and testing might help. Some of you are likely banging your head on your desk saying, "This dummy could have done all this in CFD." And you're not wrong. But OpenFoam looks more complicated than foam board, and ANSYS or Autodesk packages are out of my price range. So I'll just keep building and testing. I'm always playing around with new ideas, and I love being able to show them to all of you. If you want to help me push this project further, subscribe to the channel. Or join my Patreon. I'll be posting new ideas, updates, and behind-the-scenes ramblings that might keep other nerds like me curious to learn about something new. Thanks for sticking around. I don't know what the next one will be, or when it'll be here, but if I keep getting awesome sponsors like PCBWay and Sigma Integrale, I'll be back with something cool.